Now we are moving towards derivation for velocity of the rocket. So for that we will consider let capital M0 be the initial mass of the rocket, capital M be the instantaneous mass of rocket moving with v velocity in vertical direction. M0 be the initial mass of the rocket. When rocket is on the surface of the earth, its mass is M0. But as it started moving in the vertical upward direction, it starts losing its mass. So when it starts losing its mass, so M be the new mass, be the instantaneous mass, means at any particular time capital M be that mass of the rocket which is moving with velocity v in the vertical direction. If small m is the mass of exhausted burned hot gases per second from the rocket. If small m is the exhausted burned hot gases, because when you see rocket launching, the some hot gases are coming out which is burnt, and this is exhausted, means it is given out, then that be the is denoted by small m. Then the rate of change of mass of rocket with respect to time, because as the time passes it is exhausting out, means small m is nothing but minus, because it is decreasing with time, and where cap dm upon dt with respect to time t. Equation 1. Here negative sign denotes the decreasing mass of rocket. Remember students, the mass of the rocket is highest when it is on the surface of the earth. When it starts moving, it will start decreasing. Let the velocity of exhausted gas relative to the rocket is minus u. Then the velocity of gas relative to the initial frame will be minus u plus v, because from the lower side it is going in the downward direction. The mass, the velocity of the exhausted gas, means if this is the rocket, it is moving with velocity v in the upward direction, and the exhausted gas is moving in the downward direction, hence the minus sign. According to the principle of conservation of Here we consider conservation of momentum. d dt of m into v, momentum, is equal to minus m times the relative velocity u plus v minus mg, equation number 2, where mg is downward pull of the rocket due to acceleration due to gravity. Now we will open this. V times dm upon dt plus m times dv upon dt is equal to, m is nothing but, from equation 1, minus is already there, minus dm upon dt minus u plus v minus mg, v times dm upon dt plus m times dv upon dt, minus of minus will give you plus, dm upon dt minus u plus v minus mg minus u times dm upon dt plus v times dm upon dt minus mg. This is v dm upon dt plus m dv upon dt. From this equation, these two are same, cancelling, we will obtain m times dv upon dt minus u times dm upon dt minus mg, m dv upon dt gives the net force or thrust acting on the rocket. Therefore, dv upon dt is equal to minus u upon m dm upon dt minus g, because m get cancelled. Now we will again modify. From this equation, dv is equal to minus u upon m times dm minus g times dt. Again we will do slight changes. dv is equal to minus u dm upon m minus g times dt. Now we will integrate. Integrating above equation, we get v times minus u log to the base e m minus gt plus c, where c is constant of integration. Equation number 3. Now we will apply the boundary condition. Now boundary condition, at when t is equal to 0, mass will be equal to m0, initial mass, and velocity we will write v0. Therefore, substituting over here, v0 is equal to minus u times log e m0, we will replace m by m0, it will become 0 because t is equal to 0, plus c. From this equation, c is equal to v0 plus u times log e m0. Equation 4, substitute 4 in 3 equation, we obtain, substituting 4 and 3. V is equal to minus u log E m minus gt plus, now C term, V0 plus u log E m0, which is equal to, we will take V0 first, then these two terms we can combine, minus u times log E m plus u log E m0 minus gt. This can be written as V0. We will take u plus u log E. Now see m0, and here this minus sign means it is divided by m minus, we are remaining with gt. This is equation number 5, which is very important equation. This is velocity of the rocket. V is equal to V0 plus u times log E m0 upon m minus gt. Above equation describes the motion of the rocket, that is the velocity v of the rocket at instant t in terms of its initial mass and after time t. In case when t is small, time is small, the term minus gt hardly makes any difference, that is there is hardly any appreciable reduction in the value of velocity v. Thus we can neglect the term minus gt. Thus neglecting the effect of gravitational pull of rocket, the equation 5 becomes v is equal to, we are neglecting minus gt, so we are remaining with the equation v is equal to v0 plus u log to the base e m0 upon m. This is the final velocity of the rocket. Thank you.